What's up, period 5? Okay, so as promised, I'm going to do the quiz review problems that are going to be due tonight by midnight. When I'm done here, I will have done all the evens, all the odds. You should be able to find answers to on that link that I showed you in the last Zoom, okay? So I'm going to jump in here and get going. We're going to start with section 2.1. So this is before we started learning the derivative rules, right? You have this formal definition of the derivative here, f prime of x is the limit as h approaches 0 of this difference quotient, okay? And so we're going to just jump in here and we're going to say that f prime of x is equal to the limit as h approaches 0 of f of x plus h. So I plug in x plus h wherever x is, and then I subtract f of x, which is 3x plus 2, and I put all that over h. Like we discussed, if you plug in 0, you're going to get 0 over 0, and so you're supposed to do stuff. So I'll continue. This is the limit as h approaches 0. Distributing, I get 3x plus 3h plus 2 minus 3x minus 2 all over h. And you can see now that this is good because our constants go away, our x terms go away. I'm left with 3h over h, which will also cancel, and I get an answer of 3. Okay, so f prime of x is 3. Now, think about it, right? Now that we've done this product rule so much, you can look back here and you should know that you did it correctly. You know the derivative of this should be 3. Okay? All right, so over here, f prime of x is going to equal the limit as h approaches 0 of f of x plus h. So that's 1 minus the quantity x plus h quantity squared minus the original function 1 minus x squared all over h. Same game, you need to simplify. Limit h approaches 0. Now let's expand this out. So this is 1 minus this thing FOILed out is going to be minus x squared minus 2xh and minus h squared. Distribute the negative, I get minus 1 plus x squared all over h. And then similarly, the x squareds will cancel. The 1s will cancel. So I have the limit as h approaches 0. I can take an h out of that and say it's h times negative 2x minus h all over h, right? Which is good because our h's disappear. Our limits rule says to plug in. I get negative 2x, plus or minus 0, whatever, and you get an answer of negative 2x. Okay, so you have that the derivative is equal to negative 2x. Now, again, using our product rule, the derivative of a constant is 0. Power rule says bring the 2 down and get negative 2 times x to 1 smaller. So I know from the power rule that I did that correctly. Okay. All right. So after we dropped the formal definition of the derivative, okay, we're moving on to section 2.2, sorry. Okay, 2.2, and we got 4 problems from that. Okay, and these are just practicing the derivative. So let's jump in here. The rewrite here, just like we did in the last Zoom, you would rewrite this as x to the negative 8. Then you would take the derivative using the power rule and say it's negative 8x to 1 smaller for a final answer of negative 8 over x to the 9th. Okay, so it's really important here is this rewrite. All right, same thing over here. Let's rewrite. So this is not y prime, okay? This is simply rewriting this original function. And so when I do that, right, this guy over this guy, this becomes 5 over 2 cubed is 8x cubed plus 2 cosine. And then if I rewrite again, that's the same as 5/8 x to the negative 3 plus 2 cosine. Notice again, you guys, this is not the derivative. This is just trying to get it in a form where I have a term that I know how to apply the power rule to and another term that I can take the derivative of. So my derivative here would be negative 3 times 5/8 is negative 15/8, x to 1 smaller. The derivative of cosine is negative sine. The 2 is a coefficient, so it just stays there. So this becomes minus 2 sine of x. Okay. If you wanted to clean that up, right, you could say that that's negative 15 over 8x to the 4th minus 2 sine of x for a final answer. And we kind of talked about like why go here instead of here? Well, this problem started with positive exponents, and so I want to end it with positive exponents. Okay, 44, all of these, right? Look at these rewrites. That's what you want to take away. you want to understand that setting up the original function to take the derivative is a big thing. And here, maybe your brain said that you should do the quotient rule because this is for sure a function of x times a function of x. That would work. You can also split this up. This is a singleton denominator, so I encourage you guys to rewrite that as 2x squared over x minus 3x over x plus 1 over x. Okay, and then simplify that one more time, and that becomes 2x minus 3 plus x to the negative 1. You do not have to do it this way, but later on in the second half of the course, when we try to do the opposite of the derivative, the antiderivative or the integral, this is a good strategy on how to do that. So this is helpful later. Now, if we take the derivative, you would get 2, right? 1 times 2 is 2, x to 1 smaller goes away. Derivative of a constant goes away. Power rule minus x to 1 smaller. For a final answer of 2 minus 1 over x squared. And that is the derivative. Okay, now what if you did the quotient rule? So if you tried the quotient rule, you would say this is low d high, which would be 4x minus 3, low d high minus high d low, which is just 1, all over low squared. Okay, if you simplify that, you have 4x squared minus 3x minus 2x squared plus 3x minus 1 all over x squared. You end up with 2x squared. These guys cancel, minus 1 all over x squared, which if you again split that up, you would get 2 minus 1 over x squared. Okay, and so probably with the quotient rule, you might stop here. That would be acceptable as well, right? Algebraically, these are the same thing. Okay, all right, so now we jump into a little bit different topic. You're supposed to find the equation of a tangent line. So definition-based student, tangent line. I need a point, check, and I need the derivative at that point. Okay, and so clearly, this is what gives you your starting point. Your definition tells you what you need. Since I don't have that, I want it. Well, let's first find y prime. Y prime power rule, 3x squared plus 1. Y prime at a value of negative 1, I simply plug in, and I get a value of 4. And so when I have that, remember what this tells me. In order to write an equation of a line in point-slope form, I need a point and a slope. This is the slope of the tangent line at an x value of negative 1. And so my line would be y equals the y value plus the slope times x minus the x value would be plus 1. Okay, and that is your tangent line. Cool. All right, moving on to section 2.3. We've got, let's see how many we got here. 6 more problems, so we should be good. So try to stay with me here, hang in. You can always pause it. That's the benefit of a video and come back to it later. I think in the book, it says, find this using the product rule. That's fine. We can do it that way, but you don't have to do derivatives any particular way. That's just a textbook trying to tell you guys how to do this. You could also distribute that if you wanted to, and that would work as well. But we'll follow the rules here, and it says use the product rule. So remember that square root of s is s to the 1/2 times 4 minus s squared. So g prime, using the product rule, will be first times the derivative of the second, which is negative 2s, plus the second, 4 minus s squared, times the derivative of the first, which would be 1/2 s to 1 smaller, or negative 1/2. Okay, calculus is over. The rest is just algebra, okay? And it can get annoying, for sure. So what happens here? Well, you get negative 2, and then you're supposed to add the exponents. I have a 1/2 plus 1, or 3/2, s to the 3/2. Okay, and then we've got a plus here, and then we're going to distribute this to the 4. 1/2 of 4 is 2, and I have s to the negative 1/2. Then I distribute it to this, which would be negative 1/2, and s squared times s to the negative 1/2. When I add those up, right, 2 plus a negative 1/2 is 1 1/2, or 3/2. Okay. All right, so it seems like we can combine these. I've got negative 2, and I take away another 1/2, which is negative 2 1/2, or negative 5 halves s to the 3 halves plus 2 over the square root of s, because negative 1 half goes downstairs, square root. My s's look a lot like 5s. Sorry about that. Okay. All right. Find f prime over here. This is a setup for a quotient rule. And so we'll say that f prime of t is equal to low t cubed d high negative sine. Low d high minus high d low all over low squared. Okay. And let's rewrite this as negative t cubed sine of t minus 3t squared cosine of t all over t to the 6th. You can see here that I can take out a t squared from the top. So if I do that, I take out a t squared, I'm left with negative t sine of t minus 3 cosine of t over t to the 6th. For a final answer, f prime of t would equal negative t sine t minus 3 cosine of t all over t to the 4th. Okay. Quotient rule, memorize, right? But you guys are distant, so just make sure you have it next to you and you understand how to apply it. Okay, so we're back to a tangent line, underline, definition. I need a point. I've got it. I need f prime at that point. Okay, so again, this is where they want us to start. So let's find f prime here. You guys could do the product rule, but I did that up here. I'm going to do this a different way just to show you. You guys know you could FOIL this out. And so you could rewrite this as, that would be x cubed minus 2x minus x squared plus 2, right? All I did is first, outside, inside, last. And then I could say f prime, because this is just a polynomial, would be 3x squared minus 2 minus 2x. And so f prime at 0 would be 0 minus 2 minus 0, which is negative 2. And once I've got my point and my slope, my tangent line is the y value plus the slope, but the slope is negative 2, times x minus the x value, which is 0. Looks weird? Don't care. You've earned the right. Box it. Who cares that's a 0? Who cares you didn't distribute the negative 2? That is an equation of a line. And on an AP Calc test, they will take any form of a line you want to give them. Okay. All right. On 74, and the last one on this page, you're looking for where the function has a horizontal tangent, definition based. What is a horizontal tangent? Well, there's a horizontal line, right? So when you underline that, what's the slope of that line? The slope of that line is 0. F prime must be 0. So this is what you're supposed to do. Find where f prime is 0. That's a mathematical translation of that question. So let's first find f prime. So f prime is low, x squared plus 1, d high, which is 2x, low d high, minus high, d low, all over quantity low squared. Okay. All right, now we want to know, where is this thing equal to 0? So, you gotta take a second here. Let's talk about a fraction a over b. When does a fraction equal 0? A fraction is going to equal 0 when the numerator is 0. You don't care what the denominator is, right? You're assuming it's not also 0. That's an assumption, but you really, to solve this, you just want to find where is the top equal to 0. So when you have a fraction here, you want to know, when does the top equal 0? You don't care about that, right? Also, just think about the denominator. That's never going to be a 0 value. The only way that would be 0 is if x squared equals negative 1, and that can't happen. And so translation here, you only care about the top, which is x squared plus 1 times 2x minus x squared times 2x. And when does that equal 0? Okay, so that's a really big algebra concept here that we're going to use a lot. So make sure you understand a fraction is 0 when only the numerator is 0. All right, so let's go ahead and solve this. And this gives us 2x cubed plus 1 minus 2x cubed equals 0. That's awesome. Is that right? 2x cubed plus 2x. I said it, but I didn't write it. Okay, minus 2x cubed. Those go away, and I get 2x is equal to 0, which will happen only once at an x value of 0. Now, if my memory is correct, the directions of these in the book say verify, right? Go graph this and make sure that it has a horizontal tangent when x is 0. Okay, and you could just quickly verify your math. This would be 0 plus 1 is 1 times 0 is 0 minus 0, 0 minus 0 over 1 squared will definitely be 0. So if the derivative is 0, you have a tangent line that has a slope of 0. Okay, cool. All right, 2 more. The second one, this is another practice, right? I just kind of shortened the directions here. Horizontal tangent, that's asking you to find when is the derivative equal to 0. All right, so f prime, quotient rule again. Low, x squared minus 7, d high, which is 1, right, the derivative of x. Low d high minus high, d low, which would be 2x, all over low quantity squared. Okay, and when does this equal 0? It's the same game here, right? This could technically be 0, right? If x was equal to the square root of 7, this function would be undefined. Okay, so let's just run with this and hope we don't get square root of 7 as our answer. So what we know is that this will be 0 when the top, when x squared minus 7 minus x minus 4 times 2x equals 0. That's what we want to find. And so if I simplify x squared minus 7 minus distributing, I get 2x squared. I get minus 8x, but that minus makes that plus 8x equals 0. X squared minus 2x squared is negative x squared plus 8x minus 7 equals 0. Right? Nobody likes to factor when it's negative, so let's take that out and say it's x squared minus 8x plus 7. Okay, and what happens there? Well, that negative would stay. This would become minus 7 minus 1. So x minus 7, x minus 1 equals 0. Again, because that's x squared minus 1 minus 7 makes the minus 8 plus 7. Okay, so we get answers here of 7 and 1. So what happens at 7 and 1? When x is 7 or 1, if you go backwards, that makes this numerator 0. Okay, and checking, right, that I don't have an issue, 7 squared minus 7 is just some number. So I have 0 over number, I'm good. If I plug in 1, 1 squared minus 7, just a number squared, it's still 0 over a number, so you're good to go there. Don't forget, right, graph. And then look, right? Look at when x is 7 and 1. Do you have horizontal tangents, which is the question. That's a really important part, you guys. I know it's not something that students necessarily like to do all the time, but if you want to just make sure that you're getting an answer that makes sense to the question, it's a really good process. All right, so to finish this up, they're asking us for the second derivative. This is a double. These guys are called prime, right? So this is a double prime. That's just the second derivative of x. Okay. All right, so the first derivative of x would be, that just becomes 1. This becomes negative 64x to 1 smaller, making the second derivative of x, that disappears. 3 times 64 is 180 plus another 12, so 192 positive. X to 1 smaller for a final answer of 192 over x to the 4th. Okay. All right, you guys, I'm sorry we couldn't Zoom today, but that's all I did for periods 1 and periods 3. So you should be good with this. What I'm going to do, you guys, is on Monday, I'm going to add in, like I said, a 1 o'clock review for you guys. I'm going to answer some questions. I'm also going to come to that Zoom with some maybe quiz problems that I think will be difficult and give you guys some examples. So showing up to that Zoom will probably benefit you unless you're good to go and you're feeling real good about everything. Okay. All right, you guys, have a great 3-day weekend. Remember, your 3 assignments are due tonight by midnight, so please get those in for full credit. Make sure you watch the 2 lessons on Edpuzzle, not YouTube. And next week, we'll take our quiz on Tuesday. We'll review for a couple days, and then we'll take our Chapter 2 test on Friday. Take care, guys.